Hello everyone, this video I will show you how to use this KCS firmware with our ESP32 board so that you can create the automation on the Tuya application. And at the first, let's look at how to use the analog input and the DAC output. You can see here, that is our A4 board. Actually, you can use the KCS firmware in any of our ESP32 board. This is Tuya application that have output, input, and the analog, so that we can monitor and control this relay remotely by internet. So you can see here I can turn on and turn on and turn off, and this relay, that is remote control. And this is the input state. You can see if you have trigger this digital input and trigger this digital input 1, so that will be green. You can see here. And the third page, that is analog. You can see here, that is ADC, and this is DAC. That is for 0 to 5 volt input, and the sound channel is for 4 to 20 milliampere. So that according to your board as a hardware resource. So we can test it, such as this A3 and A4. That analog input 3 and analog input 4, that is convert input 0 to 5 volt. You can see here, that is channel 3, this is channel 4. So here on the PCB board, that have 3 volts. You can see here. We can test it. Actually, you will connect with your sensor, analog sensor. And this point, just for my test, you can see here, that about 3 volts. So we can let this part, I can test it for A3, analog input 3. So you can see if I short for this 3, you can see here, the voltage is monitored 3.2 because have some difference is correct. So this is have monitored the voltage remotely. If I release my cable, you can see the voltage will be changed to 0. So this can remote monitor the analog input. And here you can see that is the DAC, that is digital to analog output. That DAC is for 0 to 10 volt. So this have 2 channel DAC that have just this one, DA1 and DA2. So you can see I can use this multimeter. I can test it. You can see here. You can see I have tested this digital analog output channel 1. So that you can see here. I can change this scroll bar. And you can see the voltage is changed. This is 65%. That is the voltage. If I change to 100%, almost 10 volt. So this can, according to your finger, you can change the different voltage output. Usually this can use for the dimmer and use for the motor speed change. So this is channel 1 and the channel 2 is thin, so you can very easy to change this different output. Okay, let's look at how to create the automation according to this analog input. Before we have tested the digital input, trigger this digital output. So this time you can see we can click and sync mode. You can create sync mode, and one device state is changed. You can see here. I have used the A4 board. You can choose A4 board. This time you can see I can choose this ADC3. This is channel 3 of analog input. And here you can see that can input the number. That the max is 4095. So you can change this percent. That means the range, the 0 volt means 0. And this is 4095. That means 5 voltage. So if you want make a sense mode when the voltage greater than half of the 5 volts, such as the 3 volt, I almost can change to this half of this percent and greater than, that means greater than, and this is equal, and this is small, and this is large. So you can click next. And the action just then, you can see here, I can add the task, run the device. So such as I can turn on this A4 board relay 1. That relay 1 is the light. So I can click, let the light is on. So I can click save. And next, and then we can press this save and enable this one. And here you can see if the analog 3 is greater than this number, and then the relay will be on. Okay, let's test it. So let's look at this monitor and connect with this 3 volt. Okay, you can see when the volt is 3 and this relay is on. So that is for automation. When if the analog input, the value is high or low or equal, so that you can control this relay output for turn on and turn off. So this is for automation and set by this Tuya application. Now I can turn off. Okay, this is how to use the analog to make the sense mode. Thanks for watching.